The way I would do these complete factoring problems is to start by practicing the distributive property. So if we just, think about distributing x squared, we would get 7x and 4x, so a total of 11x. I'm trying to save some space, and the last term of 4 times 7 is 28. But then you still have this 2 that's in front, and when you distribute that in, you get 2x squared plus 22x plus 56. And the reason why I like to do the problem this way is because we're going to go from this form and go backwards. And I want you to recognize that you should do the greatest common factor first. That'll help you. So as I move on to the next one, we start distributing. We do have 2x squared. The outside would be 6x. The inside would be negative 5x. So that's a total of 1x. And then negative 5 times 3 is negative 15. But again, you have that 5 that's in front. So you need to distribute that 5 into the problem. 10x squared plus 5x. Let's see. 15, 30, and 60, 75. There we go. Don't be afraid to use a calculator. The next one's a little fun because if you recall, as you distribute, the outside and inside terms will actually cancel each other out. You would have a positive 5x with a negative 5x, but you still need to consider this 3 that's in front. So this final answer after you distribute it in would be 3x squared minus 75. So then the next one, pretty similar stuff, just a little bit different. The outside and inside terms will cancel. So it's 9x squared minus 4, because the 6x minus 6x will cancel. But with that 4x in front and you distribute, you'll actually get 36x cubed minus 16x. So a little bit different, but still doable. So as I mentioned before, the whole goal is that you're recognizing greatest common factors. So if we were to do this problem, the whole point is, if we're completely factoring, we don't want to have 2 correct answers. So that's why, I guess I need to be careful, because both of them are correct factorizations. They're just not the completely factored. Because if you FOIL this out, you would get 2x squared plus 2x minus 6x minus 6. And that's equal to what we had up here. But if I did the next one, we get 2x squared minus 6x for the outside terms, plus 2x minus 6. And notice the similarities between these two things. So they are both correct, but they're not completely factored, because we have, if you look in it, we have greatest common factors inside each piece. So whether you're looking at this one right here, you could have done a greatest common factor of a 2 out of that, and you would have had x minus 3, and then that x plus 1 would still be there. But if you did this other one, this greatest common factor was a 2, and it factored out to be x plus 1, and then we leave that x minus 3 alone. And I want you to recognize that those two things are equal. But if I were to do the complete factorization of this one, I would suggest doing the greatest common factor first. At least this is how I would do the problem, where you factor out the 2 out of the x squared minus 2x minus 3. And then from there you could say, oh yeah, factors of 3 that add to be negative 2, it has to be negative 3 plus 1. So I would rather you factor the problem this way. But no matter what, you should get the right answer. So the reality is, the way to do the problem doesn't really matter as long as you completely factor and you find the greatest common factor. So again, my suggestion is to do the greatest common factor first. A 4 goes into all of these problems. Plus 3x minus 10. And now what are factors of 10 that add to be 3? 5 and 2. So I'd like to see you write the answer this way. That is completely factored with the greatest common factor in front. Same thing with the next one. You could factor out a 6 out of that. And now this is a difference of squares. Just a reminder to look for difference of squares. Stop right there. That 6 is still in front, and to get x squared is x times x, and to get 4 is 2 times 2. Make one plus and make one minus, and you have the right answer. If you look at the next one, greatest common factor at 2 in front. 10x plus 25, and factors of 25 that add to be 10 are 5 and 5. And just so you're aware, you don't have to write x plus 5 twice. You could actually just write it once squared. Okay, but that is the same thing as x plus 5, x plus 5. And then this last one here, I would factor out a 3. 25 minus x squared. Oh, another difference of squares. 5 times 5, x times x. Make one plus, make one minus. So as we look at the next exercise, it's getting a little bit more complicated because not only do we have a greatest common factor of 5 here, plus 11x, let's see, 21. Well, now we have to think strategically about, 2x times x gives me that piece. Or you can do what I like to call the AC method, that 2 times negative 21 gives me negative 42. And I'm just thinking about how 14 and 3, positive 14, negative 3. So the way I need to get 14 is if I did 2x times 7, and the way to get 3 would be 1 times 3 and make that negative. So we're mixing in a greatest common factor with a little bit trickier of stuff. With the next one, again, I believe a 3 goes into all of those, so it would be 4x squared. If you need help, you can do 57 divided by 3, 19, minus 5. And again, you could think about doing that AC method of 4 times negative 5 is negative 20. So I just have to do 20 minus 1. Well, that's going to be pretty easy for me because the only way to get 20 would be if I did 4x times 5 and then minus 1. And again, you can double check my work. Maybe as we progress, I'll show you other shortcuts to doing this. Now, as we look at the next one, if you look, there is no greatest common factor. Nothing really divides all 3 of these numbers. Okay, sure, 1 does, but we don't care about 1. So these are bad guesses for letter B. And the reason why there's bad guesses is 2x plus 2 has a greatest common factor. 4x plus 6 has a greatest common factor. And it is impossible for a trinomial who has no greatest common factor to have factors that have a greatest common factor. This is an impossible thing to happen. And while we're at it, we could also say that these would be bad guesses because if you were to examine 6, as far as, are you going to have 1 and 6? Are you going to have 2 and 3? Or flip-flop them? It doesn't really matter. No matter what, one of them is going to have a greatest common factor. So is it possible? No. Because no matter what, you would have another greatest common factor. So the whole point of this is so that you have an intelligent guess that the best option is going to include 4x and x. And as you go through your process, maybe as you're guessing, factors of this would be negative 24, and it would be 8 minus 3. Well, the only way to get 8 is if you did 4x times 2, and then minus 3, and then this would be a good or correct answer. So as we talked about the intelligent guessing, maybe you're ready for it, maybe you're not, but if we look at 6 times 6, we're looking at 36, and the factors of that to give us negative 13 would be negative 9 and negative 4. But again, I don't know how good you would be at just intelligently guessing, but the only way to get negative 9 is if you had a 3x times a 3. And so if this is 3x, then this must be a 2x. So the only way to get negative 4 if it was negative 2 times 2x. And obviously I have a lot of practice doing this, so you might not be ready just to have intelligent guesses. I can talk more about other options outside of this video. So 12 times negative 8 is negative 96. And we need factors of negative 96 to give us 29. And they have to subtract, so I might just try 96 divided by 3. 32 minus 3. There we go. So another option, instead of just guessing and checking, is you could actually go through a process that we'll examine in a little bit, that you could factor out what's common there, 4. So it'd be 4x, 3x plus 8 minus 1, 3x plus 8. And then from there, you just write down the like things once, and then your other ordered pair once. Like I said, you might not be ready for this. I can talk a lot more in class about these problems. And we should be ready for the homework now.